In this video, we will solve the problem number 17 and problem number 18 from Hall and Knight Higher Algebra, Chapter 3. So, let us first look at the problem number 17. The weight of a circular disc varies as the square of the radius when the thickness remains the same. It also varies as the thickness when the radius remains the same. So, what they are telling you here is that the weight of the disc is proportional to the square of the radius. So, it is proportional to r square, and it is also proportional to the thickness. So, let us say that thickness is called by t and there is some constant k. So, the weight of the disc is actually given by some constant k times r square t. Now, we have been given that there are two discs, they have their thickness in the ratio 9:8. So, we have disc 1 and disc 2. So, we have thickness T1, T2, weight is W1, W2, radius is R1, R2. So, they have given this ratio T1 is to T2. T1 is to T2 is equal to 9/8. So, we have to find the ratio of their radius if the weight of the first disc is twice that of second. So, we are also given W1 by W2. W1 by W2 is equal to 2. Why? Because the weight of the first disc is twice that of second. So, with this knowledge, we can find out W1 by W2 is equal to k times R1 square by T1 divided by k times R2 square by T2. So, this will actually give you R1 by R2 square times T1 by T2. Now, what is W1 by W2? W1 by W2 is equal to 2. So, what is R1 by R2? This is equal to 2 times T2 by T1. Now, what is T2 by T1? T2 by T1 is 8 by 9. So, it is 2 times 8 by 9. So, therefore, we get R1 by R2 is equal to square root of 8 times 2 is 16 by 9, and therefore, we get 4 by 3. This is problem number 18. At a certain regatta, the number of races on each day varied jointly as the number of days from the beginning and end of the regatta up to and including the day in question. This is a little bit confusing statement as far as I am concerned. This was a little confusing statement for me, and it took a little time for me to understand what this problem is all about. Anyway, so regatta is an event of boat race or yacht race. So, what this problem is saying is that this event was held for some number of days. Okay, let us say that it was held for p number of days. This was the entire duration of this event, p days. Okay, so the regatta was held for p days. Now this question is saying that at a certain regatta the number of races on each day, so if n is the number of races, n, this is varying jointly as the number of days from the beginning. So if x number of days has passed, so it is x, and the number of days from the end of the regatta, so it is p minus x times k. So what this problem is saying is that suppose the regatta was, I am just giving an example, suppose p was equal to 30 and today is day number 1. So the number of races on this day will be actually equal to some constant times 1 times 30 minus 1, which is 29. So there will be 29 races times some constant. If the number of days is equal to 2, so it will be k times 2 times 30 minus 2, which is 28. So this is the meaning of this question. Okay, now once we know this, we are given that on 3 consecutive days there were respectively 6, 5 and 3 races. Okay, so let the 3 consecutive days be x minus 1, x and x plus 1, right. These are the 3 consecutive days. So what it is saying is, on the x minus 1th day the number of races were 6. So we had 6 is equal to some constant k, x minus 1th day times p minus x minus 1. Then we had on the xth day we had x times p minus x, and on the x plus 1th day it was k times x plus 1 times p minus x plus 1, right. So these are the equations that are coming directly from the statements given in the problem. So let us say that this is equation number 1, equation number 2 and equation number 3. Let us divide equation number 1 divided by 2. 1 divided by 2 will give you 6 divided by 5 is equal to, k's will cancel out each other. So you have p times x minus 1, which can be written as px minus p minus x minus 1 square. So minus x minus 1 square will be minus x square minus 1 plus 2x divided by x times p minus x. So this will be equal to px minus x square, right. Now just apply componendo and dividendo on this equation. Okay, on this equation apply componendo dividendo. Okay, so let us say 6 minus 5 is equal to 1 divided by 5. This should be equal to numerator minus denominator. So, p x minus x square will cancel out, because p x minus x square minus p x minus x square will cancel out. So, what you will be left with is 2x minus p minus 1 divided by px minus x square. So, let us call that this is equation number 4, right. Similarly, let us say we do equation number 3 divided by equation number 2, right. So, again k's will cancel out and you will get 3 by 5 is equal to, so x plus 1 times p is p x plus p minus x plus 1 square. So, this will be equal to minus x square minus 1 minus 2x divided by px minus x square. Now, again we will apply the componendo and dividendo rule. So, 5 minus 3 is equal to 2. So, this is equal to 2 by 5 will be equal to px minus x square minus this whole expression. So, again px minus x square will cancel out and what you will get is, you will get 2x minus p plus 1 divided by px minus x square. I hope so far it is clear what I am doing. So, let us call that this is equation number 5, right. Now, we have equation number 4 and we have equation number 5. What is the value of 5 divided by 4? This is 2 by 5 divided by 155. So, this will be equal to 2 is equal to px minus x square will cancel out. Okay, we are cancelling this out because px, and we are assuming that px minus x square is not equal to 0. So, px minus x square will cancel out and you will get 2x minus p plus 1, this numerator over here, divided by 2x minus p minus 1, right. Now, again apply componendo and dividendo on this equation, right. You can take the cross multiplication if you want. I am just using componendo and dividendo rule so that you know how to use it. So, what we are going to do is we are going to say 2 plus 1 divided by 2 minus 1, that is numerator plus denominator divided by numerator minus denominator. So, you get numerator plus denominator. So, ones will cancel out. So, you get 2 times you get 2 times 2x minus p divided by numerator minus denominator. So, 2x minus p will cancel out and 1 minus minus 1 will be 2, right. So, this implies that, so what we get from this equation is 3 divided by 1 is equal to 3. So, we get 2x minus p is equal to 3. We will call this equation number let us say 6, right. So far I hope that this is clear what I am doing. Now again let us look at equation number 4. Okay, again we are looking at equation number 4. So from equation number 4 we get px minus x square is equal to 10x minus 5p minus 5, or x square plus 10 minus p x, that is I am taking x square and px on this side, on the right hand side, minus 5p minus 5 is equal to 0. Similarly, from equation number 5, we get 2px minus 2x square is equal to 10x minus 5p plus 5, or 2x square plus 10 minus 2p x minus 5p plus 5 is equal to 0. So, if this was equation number 7, this was equation number 8. We know that 7 and 8 are equal, both are equal to 0. So, we can simply subtract this equation, or we can say equation number 8 minus 7 gives us 2x square minus x square is equal to x square plus 10 minus 2p minus 10 minus p. So, 10 minus 2p minus 10, and minus p will become plus p x, minus 5p and minus 5p will cancel out, and you have 5 minus 5, minus 5 becomes plus 10 is equal to 0, correct. So, 10 and minus 10 cancel. So, you get, so from here I think we will have to go to the next page, because so we will remember this equation so far. Okay. So, let us copy this because it is useful. And let us go to the next page. Yeah. So, this equation is useful, and we will also copy this equation because this is also useful. Okay. So, Let us solve this further. So, this becomes x square minus 2p plus p is minus px plus 10 is equal to 0. Now, 2x minus, from here we get p is equal to 2x minus 3. Let us put the value here. So, this implies that x square minus 2x minus 3 times x plus 10 is equal to 0. So, x square minus 2x square minus plus 3x plus 10 is equal to 0. Bring everything to the right hand side. So, x square minus 2x square is minus x square. So, minus x square plus 3x plus 10 is equal to 0, means that x square minus 3x minus 10 is equal to 0. So, we have to find two numbers whose product is minus 10 and sum is minus 3. So, minus 5 plus 2 is equal to minus 3, minus 5 times 2 is equal to minus 10. So, this can be factorized as x minus 5 x plus 2 is equal to 0. So, we have x is equal to 5 or x is equal to minus 2. Now, x is equal to minus 2 is a redundant answer. So, this is meaningless. X is equal to 5 is a meaningful answer. So, what we had to prove or what we have to find? We have to find which days were these, that is, what were the day number when the respective races were 6, 5 and 3. We have said that the days were x minus 1, days were x minus 1, x and x plus 1. So, the days were four, 5 and 6. Okay. What else we have to find? How long did the regatta last? Regatta lasted for p number of days. So, p is equal to 2x, which is 2 times 5 minus 3, 10 minus 3 is 7 days. So, the regatta lasted for 7 days. Suppose we had one more question. Can we find this complete equation n? Okay. This is also easy to find. We just have to use, let us say, use x. We know, let us use equation number 2. Equation number 2 is, from 2 we have 5 is equal to k times x times p minus x. So, this implies that 5 is equal to k times 5 times 7 minus 5 is 2. So, k is equal to half. So, the number of days n is actually given by half x times 7 minus x. So, now if you put x is equal to 4, you can see that this, if x is equal to 4, which is here, you get n is equal to 4 times 3 is 12 divided by 2 is equal to 6 races. X is equal to 5, you get 5 times 2 divided by 2. So, you get n is equal to 5 races, and if x is equal to 6, you get 6 times 1 divided by 2, n is equal to 3 races, and we have verified that this is the correct equation for the number of races indeed.